Chapter 4, Metals and Non-Metals. In this chapter, occurrence of metals and non-metals, physical properties of metals, physical properties of non-metals, chemical properties of metals and non-metals, displacement reaction, uses of metals, uses of non-metals, noble gases. Intro. Elements are classified into two groups depending upon their physical and chemical properties, metals and non-metals. Generally, most of the metals are hard and have shining surfaces. Example, iron, copper, silver, tin, gold, etc. Generally, most of the non-metals are not so hard and have dull surfaces. Example, sulfur, phosphorus, etc. Certain elements, example arsenic, antimony, germanium, etc., that have properties of both metals and non-metals are called metalloids. Occurrence of metals and non-metals. In nature, metals are mostly found in a combined state mixed with many impurities. These substances are called minerals. The minerals from which metals can be extracted easily and profitably are called ores. Metals like silver, gold, platinum and mercury are found in a free state in nature. Non-metals occur in both free and combined states. Non-metals like oxygen, nitrogen occur in free state in air and in a combined state in Earth's crust. Noble gases like neon, argon, helium, etc. occur only in free state in nature. Sulfur occurs both in a free state and combined state in the Earth's crust. Hydrogen is the most abundant element in the universe, while oxygen is the most abundant element in the Earth's crust. Physical properties of metals. Hardness. Metals are generally solid and hard. They also have high tensile strength, example iron, zinc, aluminium, copper, tin, etc. Some metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is liquid at room temperature. Luster. Metals have a shining surface in their pure state. This property of shining is called metallic luster. If you take some piece of pure copper, iron or aluminium and rub their surface with sandpaper, you will see that all of them have shining surfaces. Gold has a yellow luster and copper is reddish brown. Iron, silver, magnesium and aluminium have white lustrous surfaces. Malleability. Some metals can be flattened into sheets by beating or rolling. This property of metal is called malleability, and such metals are called malleable metals. Example, gold, silver, copper and iron. Aluminium foil is used to wrap foods and silver foil is used to decorate sweets. Ductility. Metals like gold, silver, copper and aluminium are flexible and can be drawn into wires. This property is called ductility and such metals are called ductile metals. Good conductors of heat. Metals allow the heat to pass through them easily and therefore are good conductors of heat. This is a reason that metals are used to make utensils. Good conductors of electricity. Metals allow the electric current to pass through them easily and therefore are good conductors of electricity. Silver and copper are best conductors of electricity, followed by gold and aluminium. High density and high melting point. All metals have high densities but they differ in their densities. Metals like gold, silver, mercury and iron have high densities while potassium, sodium, calcium, magnesium and aluminium have low densities. Lithium is the lightest metal with least density. Metals have high melting and boiling point except sodium and potassium that have low melting and boiling points. Sonorous. When metals strike each other or strike with a hard material, they produce a ringing sound. Such metals are called sonorous. Example, iron, brass and copper. Bells, wind chimes and musical instruments are made of such metals. Physical properties of non-metals. Physical properties of non-metals are almost opposite to those of metals. Non-metals exist as solids, carbon, sulfur, liquids, bromine or gases, oxygen, nitrogen. Non-metals are not so hard and strong except diamond, which is the hardest substance known. They are dull or lustreless in appearance except iodine and diamond. They are neither malleable nor ductile. Instead, they break down into powdery mass on hammering. Example, coal, graphite, sulfur, etc. They are bad conductors of heat. They are bad conductors of electricity except graphite. They are not sonorous as they do not produce any sound on being hit. Non-metals have low melting and boiling point except carbon, silicon and boron, which have very high melting and boiling point. Diamond and graphite both are made of carbon, but they differ in their physical properties. They are called allotropes of carbon. Chemical properties of metals and nonmetals. Metals and nonmetals also differ in their chemical properties. Reaction with oxygen. Metals and nonmetals react with oxygen to form oxides. Similarly, most metals react with oxygen to form basic oxides. Metals like sodium and potassium react with oxygen readily even at room temperature and catch fire on reacting, so they are stored in kerosene. 4Na sodium plus O2 oxygen gives 2Na2O sodium oxide. Metals like copper react with oxygen only on heating. Silver and gold do not react with oxygen. 2Cu copper plus O2 oxygen heats gives 2CuO copper oxide. Metals like iron, copper, aluminium corrode on exposure to moist air for long time. Copper acquires a dull green coating when exposed to moisture. 2Cu copper plus H2O plus O2 plus CO2 moist air gives CuOH2 copper hydroxide dull green coating plus CuCO3 copper carbonate. Iron rusts slowly in moist air and acquires a reddish brown coating of iron oxide called rust. 4Fe iron plus 3O2 plus H2O moist air gives 2Fe2O3 iron oxide reddish brown coating plus H2O. The chemical reaction that takes place when a material, mainly a metal, is exposed to air and moisture is called corrosion. Corrosion of iron is called rusting. During the process of corrosion, metals are deteriorated. Similarly, phosphorus burns in air and forms phosphorus pentoxide, which is also acidic in nature. 4P phosphorus plus 5O2 oxygen gives 2P2O5 phosphorus pentoxide. Therefore, oxides of most of the nonmetals are acidic in nature. Reaction with water. Metals react with water to form metal oxide or metal hydroxide and hydrogen. More reactive metals react more vigorously with water. Sodium, potassium and calcium react vigorously with water and form soluble hydroxides and hydrogen gas. A lot of heat is generated. 2Na sodium plus 2H2O water gives 2NaOH sodium hydroxide plus H2 hydrogen. Magnesium reacts with boiling water or steam to form magnesium oxide and hydrogen. Mg magnesium plus H2O water gives MgO magnesium oxide plus H2 hydrogen. Aluminium reacts with water to form aluminium oxide, which forms a layer on the metal surface and prevents any further reaction. 2Al aluminium plus 3H2O water gives 2L2O3 aluminium oxide plus 3H2 hydrogen. Iron reacts with steam only when it is heated strongly. Metals like silver, gold and platinum do not react with water, acids and bases and are also called noble metals. Non-metals generally do not react with water. Oxygen dissolves in water to some extent. Highly reactive non-metals like phosphorus catch fire when exposed to air, so they are stored in water. Reaction with acids. Let us observe the reaction of metals and non-metals with acids. From the above activity, we see that metals react with acid to form corresponding salt and hydrogen gas. The hydrogen gas burns with a pop sound when a burning matchstick is brought near the mouth of the test tube. Metal plus acid gives salt plus hydrogen. Heat is also evolved. More reactive metals, sodium and potassium, react vigorously with acids. 2Na sodium plus 2HCl hydrochloric acid gives 2NaCl sodium chloride plus H2 hydrogen. Copper does not react with the diluted hydrochloric acid even on heating, but it reacts with sulfuric acid. Silver and gold do not react with acids. Non-metals do not react with acids. As metals react with acids, so food items containing acids like pickles and curds should not be stored in containers of aluminium or iron. The reaction of acid and the metal may result in toxic substances. Reaction with bases. Let us observe the reaction of metals with bases to be demonstrated by the teacher. Most metals do not react with bases. Only some metals like aluminium, zinc, and lead react with strong bases like sodium hydroxide to produce hydrogen gas. Reactions of non-metals with bases are complex. Displacement reactions. After studying the above reactions, we have seen that different metals have different reactivities. Potassium and sodium are the most reactive, while silver and gold are the least reactive. So we can arrange the metals in decreasing order of their reactivity. Such an arrangement is called reactivity series of metals. Note, hydrogen, though a non-metal, is also in this series as it also forms positive ions like metals. In this series, the most reactive metal is at the top while the least reactive metal is at the bottom. A more reactive metal can displace a less reactive metal from its salt solution. Such a reaction is called a displacement reaction. Uses of metals. Copper is widely used for making electrical wires and copper coals are used in various electrical appliances. It is also used for making utensils and many useful alloys. Brass is an alloy of copper and zinc while bronze is an alloy of copper and tin. An alloy is a metallic substance made by mixing two or more metals or a metal and a non-metal. Iron is used to make utensils, tools, machines, equipments, etc. and also used in building construction. Steel and alloy of iron, carbon, nickel and chromium have many uses. Pig iron is a hard and brittle form of iron with high carbon content used to make pipes, sinks, etc. Wrought iron is a tough malleable form of iron with very less carbon content used to make nails, bolts, etc. Aluminium is used to make utensils, electrical wires, etc. Aluminum foil is used to pack foods. Aluminum alloys are lightweight and strong, so used to make parts of aircrafts and cars. Mercury is used in thermometers. Gold, silver and platinum, the noble metals, are used to make jewelry. They are also used to make protective and decorative coating on the other metals by the process of electroplating. Zinc is used in dry cells. It is also used to coat iron articles to prevent them from rusting. This process is called galvanization. Uses of non-metals. Oxygen is inhaled by living beings to survive. It is necessary for the process of combustion. It is used to burn fossil fuels and helpful in the extraction of metals from their ore. Sulfur is used in medicines and antiseptic ointments. It is used to prepare sulfuric acid used in industries. It is used in vulcanization of rubber, which makes rubber hard for making tires. Iodine solution is applied on wounds as an antiseptic and also used in making iodized salt. Phosphorus is used for the preparation of fertilizers and in making of matchbox and fireworks. Graphite is used for making electrodes of dry cells. It is also used as lubricant. Graphite is used to make lead of pencils. Silicon has a wide use in electronic and computer industry. It is used to make transistors, microchips and solar cells. It is also used to prepare silicones which are used to make waterproof clothes, grease, etc. Nitrogen is used by the plants to prepare protein. Liquid nitrogen is used for preserving blood and other donated organs as it is inert in nature. It is also used in the preparation of nitrogenous fertilizers. Hydrogen is used for the manufacture of ammonia gas required for the production of fertilizers. Oxo-hydrogen flame is used for welding and cutting metals. Chlorine is used as a bleaching agent in industries and also used in the preparation of bleaching powder and pesticides. It is also used to disinfect water in municipal water treatment plants. Noble gases. Gases like helium, neon, argon, etc. are non-reactive and are called noble or inert gases. Helium is used to fill balloons as it is lighter than air. Neon is used to make glow signs or neon sign boards. Argon is used to fill electric bulbs. It gives a green glow when mixed with a small quantity of mercury. This mixture is used in fluorescent lamps. Keywords: malleability, the property of metals to be beaten into sheets. Ductility, the property of metals to be drawn into wires. Sonorous, terms used for the metals that produce sound on hitting. Corrosion, the chemical reaction that takes place when a metal is exposed to air and moisture. Rusting, corrosion of iron. Noble metals, those metals that do not react with water, acids and bases. Displacement reaction, the reaction in which a more reactive metal displaces a less reactive metal from its salt solution. Reactivity series, the arrangement of metals in decreasing order of their reactivity. Noble gases, the non-reactive or inert gases. Summary: elements make up the various substances or materials. Elements are classified as metals and non-metals. Metals have luster while non-metals are non-lustrous. Metals are hard while non-metals are not so hard. Most of the metals are malleable and ductile, while non-metals are neither malleable nor ductile but brittle. Generally, metals are good conductors of heat and electricity, but non-metals are poor conductors. Generally, metals have high density, high melting and boiling point, but non-metals have low density, low melting and boiling points. Metals are sonorous, but non-metals are not. With oxygen, metals form basic oxides while non-metals form acidic oxides. Few metals react with water to produce metal hydroxide and hydrogen gas. Generally, non-metals do not react with water. Metals react with acid to form metal salt and hydrogen gas. Generally, non-metals do not react with acids. Some metals react with bases to form hydrogen gas. More reactive metals displace less reactive metals from their salt solution. Metals and non-metals have wide application in daily life. Gases like helium, neon, argon are called inert gases or noble gases.